So I'm a solid state chemist, I guess by training. I've been growing crystals for just over 20 years now. Started as an undergrad, and then to get my doctorate was continuing with crystal growth of various materials. I've produced intermetallics, superconductors, semiconductors, and then the journey that led me ultimately here was going from industrial grade sapphire production for semiconductor chips and LEDs. And then from there, ultimately, what I did was looked at the kind of future state of materials as it was 10 plus years ago and said, what material do I want to grow next for, market potential in a variety of different industries? And that ultimately led me to diamond. For lab-grown diamonds, gemstone versus technical applications, the two biggest factors are form factor and quality. So what do I mean by form factor, right? A 2-carat diamond, 5 millimeters tall in its finished form, generally is grown around to 6 millimeters in height, give or take, and the rough block itself may be anywhere from 6 to 9 carats of rough weight. So relatively large. Of course, you can grow bigger today, but that's still a fairly large chunk of diamonds, like a centimeter cube, basically. And from a technical application perspective, most of the market is looking at, for a variety of applications, what we would refer to as substrates or wafers. So usually a maximum of 1 millimeter thick, which is a far cry from 6, 7, 8 millimeters tall for the gemstone. So the form factor is very different. And then when you think about quality, you have your 4 C's for gem, which I assume you're familiar with. Clarity being kind of the easiest one to think about with respect to quality, right? Are there inclusions in your diamond? Are there cracks or other things that you don't want in there? And the way that that's generally analyzed by your gemologist is they'll take a 10x loop and look at it under a microscope to say, can we see things, right? Now, that is very, very different from the semiconductor approach, where we would use advanced analytical techniques, either some form of spectroscopy or potentially even X-ray diffraction. And ultimately what those techniques do is look at the atomic structure of the crystal. So if you think about using a 10x loop compared to looking at it atomically with X-rays, you've got something like 8 or 9 orders of magnitude different in kind of specificity. So the other simpler way to say that is, on the semiconductor side of things, the material requirements can be significantly higher, right? There's applications where for nitrogen has to be in the parts per billion, as opposed to parts per million for a gem.